Howdy hackers, and welcome to another episode of FairLight TV. This is not like a regular FairLight TV episode, because this one is also a presentation that will be originally shown on Transmission 64, the party in early December. I envy you guys who could be on location. I'm actually traveling during that week, so I will not be in I will not be able to join you anyways, but for those who are now in a party watching a screen with me on the screen, hi guys! My name is Pontus Berg. You are likely knowing me as Bacchus of FairLight. I lead the C64 section. I'm one of the three that manage the entire group, all the segments, but my predominant activity has always been on the C64. If you haven't heard of me, that will be a shame. Then I failed in my mission to make my name known. Frank Mischlik asked me to present something for you at Transmission 64, so that's what I'm going to do. And the topic he suggested for me was setting up a coding environment for coding for the C64. That does not mean coding on the C64, it's coding for the C64. But in order to go through the different options we have available for us, let's start by coding the options coding on the C64. Alright, so now we are on the other screen here, and I should start with this. So, and I'm actually starting before this. So, when you start coding on the 64, you typically fire up the machine code monitor inside your cartridge. That will be the very logical first thing to do. And you do assemble 1000, inc DO20, and then on 1003 you do jump to 1000, and then you do go 2000. And you have your first flashing water, which is sort of the hello world example of coding machine code on the C64. That's the basic and the easiest thing you can possibly write when coding machine code. But as soon as you have something that's more than 20 lines of code, I would strongly urge you to move away from the machine code monitor and go into an assembler where you edit the text in one environment, and then you assemble that to the binary code that you can eventually run. The thing that most people used when coding demos on or also general coding of anything on the C64 scene was Turbo Assembler by Omnicron. I've also seen that my 5.1 version is one of the more spread. Antitrack did the original crack of the program, and then people did their own little tweaks and patches. Most of them were sort of around ensuring that you had your favorite color scheme in the environment. I think I did a little bit more than that. I made it action replay compliant, so when you did the memory view, it wouldn't crash your action replay. And I also think that smash and return would point you back to the actual assembler so unless you change the NMI vector inside the running program, you can smash your restore and you would return. That was a handy way to do it. Turbo Assembler has a number of rather significant limitation. So in general, coding on the native machine gives you limitation of speed. You are running on 1 megahertz. You're not running on a modern PC with gigahertz and parallel processing and what have you not, multiple cores and all of that. You have a very limited storage. So when you're storing your files, you cannot like slam control save every second or every 5 seconds, because every time you save on the C64, it's adding a file to a directory, and eventually or quite quickly your disks become full. So This is where the 1581 became rather handy, and also having something like Jiffy DOS installed in the machine, so you could also save at a reasonable speed. Memory, that's sort of the predominant constraint. If you are coding anything whatsoever and you have the assembler, your source code, and also the binary sharing the same 64K of memory, that is a massive restriction. If you are coding anything that is remotely beyond or even a fraction beyond the very basics, then you would run into issues with that sort of memory constraint. For me, one of the bigger issues as well is the limited screen estate. I mean, the 64 would have 25 times 40 characters. Where if you see the screen here, that the lower two are actually occupied by information messages. It's sort of an information bar. Well, you could argue that the first one, where we are sort of pushing ourselves, is redundant. But as far as I remember, it actually sort of updated that, and there are additional information there in some of the aspects. But the lower line you cannot get rid of, because you need to have the line and the X, and if it's on insert mode and all of that simply needs to be there. So regardless of how you do it, the screen estate is very limited on the native machine. And the functionality of the assembler is also restricted. I mean, the normal 5.1 is non-macro. So if you wanted any sort of macro functionality, you would need to have the specific Turbo Assembler Macro Edition. And that one was, it had macros, but it ate another hex 1000 bytes of memory. So it started at 8000 rather than 9000. Giving you even less memory available for your binary. And quite frankly, the C64 keyboard was way better than the Spectrum. These little rubber things on the Spectrum could alone be a reason for hating it forever. But getting back to the C64 and typing on a real piece of hardware today, compared to typing on your normal PC keyboard, it's not that good, is it? No, not really, no. It's decent for its time. It was absolutely good, but you couldn't change it. I mean, it's an integral part of the machine, so you have to have that keyboard. That's what you stick with. And it has to, you simply must make do with what you have. But if you code on a PC today, you have you can select from hundreds of different keyboards that fit your need. The C64 keyboard is not one of the top 100 keyboards you would ever select, right? I'm sorry to tell you that, but that is an absolute fact. Okay, so Turbo Assembler 5.1, if you insist that you want to code on the 64 and you want to have the maximum number of restriction but still want an assembler, then the best option is Turbo Assembler. I couldn't for my life imagine why you would want to do that, but if you insist, that's where it is. Okay, the next window I'm going to show you here is the Cross Assembler by FairLight. We spend a lot of time developing our tools, ensuring that we sort of have the best tools available. So I'm not showing you the FairLight edition of standard tools just because I want to promote our stuff, but I would actually like to think that we did a lot of good when it came to developing relevant development opportunities for people. So XAS is a development kit based on Turbo Assembler. The main difference is that it's sort of running in, it's supporting the RAM expansion unit, REU, typically the 17XX, like the 1764 or something similar. 1764 was the one I had. We upgraded them to be sort of 512K, which I think was the absolute maximum you can get them to do. So what this is doing is using two banks. I've explained this before in other contexts, and I actually read up on the instructions now, and I think I got it a bit wrong, but doesn't really matter. So what you do is you run a source bank and an object bank. A source bank is where the assembler is, where the source is, and the object bank is where you place all your sort of binary resources, like the music and like the graphics and code by somebody else. Everything you just throw into the object bank. And when the machine is then assembling, it's not assembling to the RAM of the actual computer. It's assembling into the object bank. And then when everything is done, it copies down the memory of the source bank into the current bank into the source bank, and then it copies the binary the object bank into the computer RAM, and then starts the program. This is all sort of available to you. This just happens in the background. Oh yeah, thank you so much. That was my Google Home saying it couldn't connect to the internet. Sorry about that. So the cross assembler is sort of the XAS is using the same machine and the RAM expansion unit basically like a cross assembler. You only need the disk state of one machine, and everything is really smooth and really fast because you are assembling it directly into the object bank, which is then swapped in. So the only thing you need is to have this little one block routine that will get you back into the source bank. That was also written to the object bank. Unless you borked it, you would just sys where on the page where you have put that return routine. And if you totally trashed it and you would want to get everything back, what you could do is just load a little file that you would have on your disk, which is also one block big, and then boot that and then return to the source bank. So this is it was a very good way of preserving your source, because having a program going berserk would very, very unlikely trash anything in the RAM expansion unit. Unless you kind of coded RAM expansion unit programs, your programs were safe in the source bank. I could show you this as well. So the XMEM assembler, again based on Turbo Assembler, but it had one other thing in it. And these are the additional new commands. You can select object bank, select disk drive. Not everyone would want to do work with device 8. Potentially you would have your device, your 1541 as device 8 and your 1581 as device 9, and then you would save your source files to device 9. And we have support for that. That was absolutely not in the original. Hunt for labels, and then here setting the page for the return routine. But one of the more prominent additions to the kind of capabilities of the programming environment was Tronmon. That is original piece of work by Tron, Micke Olsson. Where you could actually edit like a standard machine code monitor, but you could select the bank you worked with. It could be the current CPU bank or the current computer, but it could just as well be one of the 64K banks inside the RAM expansion unit. I mean, today Vice doesn't support the RAM expansion unit inside the machine code monitor. So I'm unaware of any other mean to access and modify and inspect the RAM expansion unit content as Tronmon did already in '93. So let's see here. Here is Tronmon commands. So Tronmon 2.1 is the version that we shipped with XAS 3.3, which I think is the last version we shipped. It's sort of built on the action replay monitor syntax-wise, so that's where we took it from, but it has a number of quite nice features. Numbers, you don't need to have the preceding 0, you can just do 8 rather than 08 if you want to. And you can have commas and you can have spaces. It understands both. So that's also one of the things it could do that no other or very few other monitors would do. Bank select is where you select if you want to work with the current bank in RAM or if you want to select one of the RAM expansion unit banks. Yeah, and then it has, this is on FairLight TO/docs if you want to read up on the Tronmon. That's that page. So the third thing you can do is a cross assembler. And cross assembler would be two machines where you have the source in one machine and also the source and the assembler, of course. And then the result would be sent over some sort of connection to a receiving machine. The receiving machine would need to have some sort of receiving routine that would manage the incoming signals and boot up or whatever. There are solutions for this that has been around for a long time. You could have two C64s doing this, but predominantly the source machine and the machine that ran the assembler would be one of the bigger machines. In the first years it would be an Amiga, but sometimes like a few years later it was more and more common that other machine was a PC, and that's, I think this is more of the setup that the professional developers of the software houses were using, some sort of bigger machine that would assemble to the C64, and then the C64 would be just a slave having this little thing, the receiving routine in it, and then it would boot and then it would run. The solutions I have seen for this, they have all been so that you could store things in the C64 memory and run it. I haven't seen anything that would generate a disk for you, so it would. I haven't seen the option of like storing 10 files or a full demo on a disk and then run it. I haven't seen that. It could be that it's available. It's just me that I haven't seen it. But so that's one of the restrictions of cross development. You simply don't like generate a full demo out of it. You are generating something where you run it on the native machine. But the good thing is you are running it on the real C64. So compared to emulators, you are running it on something which is 100% compatible because it's the original thing. So of course it's compatible because it's the thing to be compatible with. But again, one of the drawbacks, or kind of the key drawback, would be that you can't build disk images unless you develop some sort of solution for that, which I don't think is available. The other drawback, if you see this as a drawback, would be the desk estate, the physical estate on your desk. You would need to have two machines, possibly two monitors, two sets of keyboards, and you would need to go back and forth between them. If you compare that to developing everything on the PC, running it on the PC and all of that, then you just need that machine. So I wouldn't rule out cross development as like something you could run today. Please feel free. I mean, it's your life. You are going to do whatever you like. It's not my kind of solution of choice, but having said that, there is nothing like really wrong with it. So if you think that is the way forward, then do that. So now we're getting into the meatier part of this discussion, and that would be using a bigger machine, because one of the things I would like to iterate is that no one will thank you for investing more pain and effort into a production than is needed. They would judge you by the result. They will not judge you by the inefficiency of your tools. So if you are going to cut down a tree, you can do it with a knife. It takes forever, and it's probably also a bit dangerous, but you can do it, and you can do it with an axe. But you can also do it with a chainsaw. The chainsaw is so much faster, and it gives you the same result with a lot more precision than the other options. But again, once the tree is down, nobody cared how you did it. They would possibly consider you a bit of a retard if you did it with a knife. But again, you took down the tree, so please feel free to use a knife. It's just not my choice. I would like to always use the tools that produces the best result with the minimum effort, right? And nothing that runs on the native C64 is the most efficient tool. Okay, it's simply not. So the options that run on the C64, you can categorize them in two packages. And I'm now doing an analogy. Us being old, I presume that several of you are almost as old as I am. When we bought our first stereos, the thing you could buy for a reasonable set of money was this all-in-one kind of package. It was the cassette deck, it was the radio, it was the amp, and on top it also had the record player. If one of those pieces, or if you are a bit younger, you might have had a CD player in that set, but the general view here is it's an all-in-one package. If the CD player broke, you basically had one part of the unit which you couldn't use. Then you needed to have, if you needed to send it to repair, you would need to send the entire thing to repair. If you found that the tape deck was substandard and you wanted a better tape deck, then you suddenly had the issue that you still had this integrated tape deck. You couldn't just pour it out and put something else in that was better, because it's a one-in-all combination, and it has the restrictions of an all-in-one combination. The same sort of setup is also available here as a development environment. This is sort of the all-in-one package options, and I'm going to show you two of them. This one is C64 Studio, the other one is CBM PRG Studio. So they are both something with like C64, and there's also something with Studio. It's quite easy to confuse them and mix them up, but yeah, so this is how it is. Let's start with C64 Studio. So what you can do here is that you can do assembler code. Let's see if there is something in the menu window here. So breakpoints, debug. This one, it doesn't include the emulated environment. That would be sort of ridiculous. So you need to install Vice, because that is the emulator it supports. But it supports the remote monitoring, so you can actually sort of remote debug using it, which is a nice feature that this has. But let's see, it has a text editor. So here you select the characters, and by clicking here and that, and yeah, I know this looks like crap, but don't kill me for it. So what you do here is you build screens out of the potential characters that you have here. And then you can have, like, this is a graphics editor, and I'm sort of retarded when it comes to painting, so I really shouldn't do this. Let's do this, and this, and custom color mapping. Yeah, I don't know. This is not the program I'm using, so I'm just playing with it here for your enjoyment, and seemingly your enjoyment here means that I don't have any clue what I'm doing. I was imagining, you do like this. Okay. Yeah. Super nice painting. So I guess this is sort of a drawing bitmap. You've seen me draw on bitmap. This is more graphics than I've done in 10 years. So that's also included. Charset editor, that's where you define the actual font, and screen editor is where you sort of make that font into screens. So if I take the A here, let's see if something, I use the alpha sign here. So if I select the alpha sign and yeah, I change that, I would imagine that's changed here. No, it is of course not. It's not using that charset that I just drawn. Ah, well, never mind. So, but it has text editor, it has like a bitmap editor, it has a charset editor, and then it also has maps. So in order for making like complex C64 games, a lot of the times where you had bigger levels, first of all, you cannot do it in bitmap. That's absolutely sort of impossible. It's too cumbersome to generate bitmap, and scrolling bitmap is also just a no-no. It's just too much data you need to shift around. I know that the Roland Brothers did VSP tricks and all of that in their game. So yes, it has been done, but that's not the route that people would probably recommend you to take when coding something like a fast-moving game on the C64. So in order to find sort of a sweet spot as a compromise between how big the levels are and how fast you can work with them, you have the characters, and then they build up tiles, which is sort of bigger blocks, and then the level itself is built up from the tiles. So just placing the characters all across X, Y would mean that you would have rather small levels, and it would still eat most of the available memory. You basically need to have something in between, which is a cluster of characters, and then you have your map would be pointing to which cluster you would be using. So some sort of level between characters and the map would make the map a lot more, a lot bigger. Let's just say a lot bigger. That would give the opportunity of having a massively big map with which doesn't consume all the memory. And here we have my little assembler code. As you can see here, you could add to your project an assembler file, a basic file, sprite, characters. So that's character set, character screen, graphics, that will be the bitmap. Map, it's probably the like the map of tiles, and then value. Yeah, I have no idea what that is, but then you can. What you do here is that you can compile, you can build, you can rebuild. So build, if you built before, it will keep track of that, so it wouldn't build the same thing again. Build and run is also launching the emulator and running your code there. Debug is sorting a debugger as well, so it's running in debug mode. So, but what I'm going to do now here is build and run. And of course it starts on another window. And I have no idea why this, I think it's my Vice that is doing that. So now it loaded, I assembled this. Woo! The little program I can actually also write in a machine code monitor. I can use it, I can poke it also using mnemonics, but or the hex code for this. But so I did this, I assembled that, and it automatically launched the Vice emulator. I did have issues. I'm not sure if I have a Vice version which is newer than 64 Studio is used to. I needed to take away the setting here. Probably won't edit file preferences, so tools. I think when running this, I needed to remove the true drive emulation on and true drive emulation off. If these were maintained, I would Vice will return an error when 64 Studio tries to launch it. Yeah, so this is it. That's C64 Studio. That's one of the all-in-one programs. No, we don't need to no, we really don't need to keep any of that, because they were nothing that you would have any sort of interest in keeping. Again, that's not a program I use at all, but a similar program, which for me is a bit more mature, is this one. This one is CBM PRG Studio. It can do one thing that the previous one couldn't, and that is some sort of music. And I'm sure you would want me to test that, but I will just show it to you. I have no idea how to do music. So again, like C64 Studio, this one could do basic, it can do machine code, you can, and of course that ends up on another screen. You can do the same sort of thing with designing your fonts. Sprites, yes, let's do a new one. Okay, so, and add a new. You can rotate them, that's nice. And you can do here you can do animations, so you can make an animation of sprites, and this is a very handy way. It's it looks really nice to draw it using this. And Scratchpad is when you make sort of yeah, a sprite composition that contains more than one sprite. So if you're making a running guy like in Summer Games and Impossible Mission, this is how you position them, so you can have like a grid of sprites that build up like a bigger object that consists of multiple sprites. No, I will not want to keep that. And screen designs, add new screen designs. Yeah, so it's pretty similar to what you've seen in C64 Studio, where you can design screens as well. This is sort of a fixed screen, and you can generate. Yeah, it doesn't really fit on my screen. It's this is my little spare screen. So, but you can make multiple screens, and but again, it's not meant for like super big scrolling games. It's more like fixed screen games, like Impossible. No, what's that? Impossible. Yeah, fixed screens, and then you change to another screen. That's how you're supposed to do this. I don't think it has the tile thing and that, or does it? Quick select. All right, lines. Oh, well, you don't see that. It's showing up on the other screen. I don't use this part of the program, so I do use it for one thing. Yeah, and I should show you this. There is some sort of support for MIDI, so you can probably connect your MIDI keyboard and then record something, or you could do this. No, where is it? Here it is. Voice 1. It's changing something here. Again, you can tell I'm not a musician, and even if I was, this would probably not be my weapon of choice. Here you do build and run, and you would have okay, let's see what happens here. I think it just installed the yeah, so this is probably the little basic program only. Yes, testing of CBM PRG Studio, which is what you saw here. So I use this for basic. So a number of the programs I've used, I've been playing with during the last few years, had basic components to it, like Sublime, and editing that on the native machine was just unthinkable. So I imported the project into this because this can do a number of nice things. You can reformat your basic code, and it's just a handy way of coding basic, that you sort of compile basic into runnable basic, but the user experience of this environment is a lot better than coding it on the real C64. So that's why I import it here and use it here, and then it will never leave here until I compile it. So that's CBM PRG Studio, which I actually do use for certain applications if they contain basic. Let's go into the more, again, the stereo analogy is where you have a separate CD player, a separate vinyl player, a separate amp, a separate radio, and then you can upgrade each of the components and to have sort of a setup where the overall capabilities of your solution is what you want. So the solution is sort of held together by that you have selected the different alternatives for the different functions you would like to have. I mean, if you bought a DAT player, you could add that. That was impossible with the all-in-one solutions because there was no way to add a DAT player. There was no like physical room where you can throw that one in. So this is the same as the normal solutions I would recommend you to use. You want an assembler, you want an emulator, you want some sort of editor where you edit your text, and you want to have some sort of glue that builds that together so it's perceived as sort of an integrated development environment, an IDE, but it's really not. All the parts are interchangeable. So if you suddenly don't like the assembler you've been using, then just throw it out. Pick another one. I mean, the only thing you need to change would be if the glue needs to be adopted or adjusted so that it would encompass your new environment with the new components that you are putting into the context. The first one we're going to show you here would be this one. I had closed that one. Let's see if this is also not something I do use myself, but a number of the professionals out there who code for a living would use Visual Studio for their kind of commercial activities. This is VS Code, so it's a free version of Visual Studio, the editor part of it, which can do most of the things that you want it to do, I guess. What you then do is add Paul Hooker's little plugin to this. So what Paul has done is writing something which integrates VS Code as the text editor with Kick Assembler as an assembler, with Vice as the emulator. It also supports C64 debugger, as you can see on the screen here, and glues that together to a coherent solution. The FairLight demo section uses this. I'm not saying they use Paul Hooker's little glue. I'm sure Pantaloon has done his own. But I guess it's doing basically the same thing as Paul is doing here. So this is the solution for syntax, for gluing it together. Syntax highlighting is of course absolutely important because you want to ensure that the visuals would immediately, by coloring, tell you if you've coded everything right or wrong, or if you just kind of have a typo error in one of the mnemonics. That syntax highlighting will tell you if it's right or wrong. Yeah, and I can scroll through it. So it has code snippet things and code completion, and Yeah, it supports basically everything you want. If this is your normal environment where you work, then this is the option you want. So follow Paul's instructions on on how to set this up. Install Vice, install yeah, whatever you need to install. You need to, yeah, Vice you need to install, and Kick Assembler you need to install, but then you need to configure it and do pick up C64 debugger when you're doing it, because that's also something you probably would like to try. It's a bit overwhelming when you try it the first time around, but it's once you get over the threshold or the hurdle of starting to use it, it's fantastic. It's something different than Vice. It can do another set of things that Vice cannot, but it has weak points where Vice is second to none as well. So I would use both always, but for most of my development I would use Vice, and then I use C64 debugger more for my low level hacking activities, because that's when I want to see the details of a running program, whereas Vice is more like running a program, and then you can interrupt it on wherever you want. But so there are different aspects that are the strong side of these two. That was a bit of a detour from Kick Assembler for Visual Studio Code by Paul Hooker. And if you are used to VS Code, installing another plugin is probably very easy for you. So this is just one of those additional plugins that you use for this. All right, and now we're getting into, and that's not the environment I'm using. I hope I was really clear with that. So I will not show you how to assemble or anything like that. I will not start any project on it. It's because you start a project and you just run it. It's quite straightforward when you see it done by somebody else. It's just setting up the environment. The last thing I will show you is the environment I use myself. So this was something that was very difficult for me. I actually paid money for software. Okay, Sublime is a super good text editor, and I know there are dozens of text editor out there for free, like Notepad++ and what have you not. I paid money for this because I wanted this very solution, and it's based on Sublime as the text editor, the editor you want in your integrated development environment. The basis is Sublime. The assembler as before is Kick Assembler. The emulator as before is Vice, but it can also support C64 debugger. The editor is Sublime, and the glue, the core of what makes this possible, is basically the same as what Paul Hooker did for VS Code. It's done by Simon Swoffa Oskarsson. So Swoffa of Noise did the thing that glues this together. It gives you the speed keys for doing a number of things. Let me see. No, I don't have his homepage here. Yeah, I had that before. That was a pity. Well, anyway, what you do here is you just type your code. Let's see, files here. When I code on the 64, I do a number of tools that are sort of just doing little things that would do a particular things on the native machine. But most of the things I code is taking something binary, importing it, patching it, sometimes patching it binary, and sometimes patching it using code, so I need to assemble new binary code into the blocks I'm fiddling with, and then saving it back to a file. and the second step of that would be exomizing or crunching or modifying the files in any other way, and in the end build a D64 as a result of that. So here I'm fiddling with Grand Monster Slam. I don't really have any real ambition of ever launching this as a crack, because FairLight already launched that as a crack back in the days. We did receive complaints that there are issues loading the game, and rather than patching Adrian's old crack, I rather do it from scratch. So this is a truly back burner that I'm sort of fiddling with just because it's sort of fun, and I wanted to to have a look because I also have the original. So what I'm doing is not developing normal, like if you are doing demos, it wouldn't look anything like this. So here I'm generating a file, and it would consist of these segments, and below that I have the segments. So this is the output file, the temp gg reloc prg. I import one file, I fill another memory area with 0. That's sort of a wasted space in the game, so it compresses better if I 0 fill it, so that's what I do. And then I import another segment, and that is the first 100 byte of that file is a relocator to the other location. So what I do here is I put it directly in that location, and then I remove the header, which is just doing the relocation. That's not needed. I squeezed several files into one file. And then there is GG patch, so there is a boot, a little startup code, which I replicated from the game. I did a reassembly of that little binary, and then and I kept all of this. Yeah, this is then something that is going to be copied to the very top of memory. Yeah, and another file and another file. So every time I need to patch, I actually use the assembler to do the patching for me. File, and then the output file. I allow overlapping because that's the whole purpose of patching. You are changing something inside an existing file. And then the segment that should be imported, that eventually needs to be patched, is this. So what happens here is basically I relocate the file because the original file is in another location. So I set the correct location for the file, and I import it, and then it becomes that file. So it was one file, it became the same file, it's just a file on another location. Normally I would have another segment that would be sort of a patch segment, but that's not needed for just relocation. But Kick Assembler can do that as well for you. And yeah, so there is something else I should show you on how to do this, and that's the bat file. So normally in my projects I have a bat file. I know the professional ones of you would have a real make file where make ensures that you don't compress a file if it's already compressed. You don't assemble a file if it's already assembled. Sorry, I'm just a layman. I don't code for a living, so I'm doing my C64 stuff, and I know that make files is a thing. I just don't use it, so I'm doing a bat file. Assembling the fixed files you saw before, so this one. Exporting all the files in their change format, and then level crunching a number of files. And then the last thing I could also show you is the last thing I'm running is generating a D64, which is also one of the things that Kick Assembler can do. I know a number of people using Kick Assembler think that feature is a bit of a bloat. I personally love it because it does. I could use a third-party program doing very much the same thing, but it's for me there is really no harm in Kick Assembler also doing it. And I should do a build D64. It's this. So you do a .disk with a number of parameters for the header, and then you just import the files and tell what they are. And here what you can also do is import a block, which is the directory art for this. Yeah, let's do F7. I can't open. Oh, what is that? Okay, let's Oh, you don't see that. Sorry. Here is the window. Now I'm just clicking the make file. Normally inside the window you would press F8, and then when you press F8 it's calling the make file. I have no idea why there is an issue, and I will promise you that I will contact Swaffa about it. It was during one of the last major upgrades of Sublime where that stopped working, so Swaffa need to do something to change something for the setup to work. So it's the glue is sort of itching here. Okay, what happened now was that I built everything. So I did the patching of the file, I run the Exomizer on all the relevant file, and then I added them to a D64. So I need to start it like this, and rather than via total commander, rather than having an automated process, which I would have had if the F8 worked. Okay, we can see the directory here. Here you also see the directory art. That was... So this block of things down here, the lower file here, is this. There seems to be an issue with those last two. Let's not mind that. I can run. we can conclude this little thing with running Grand Monster Slam, the intro of Grand Monster Slam. So Golden Goblins, it's Rainbow Arts. I can go out in style by having the Grand Monster Slam music running in the background. So thank you so much for listening. You have been listening to Pontus Berg, whom you might know as Bacchus of FairLight, trying to educate you on setting up your development environment for developing stuff for the C64, but not on the C64. I would discourage you from using the C64 as a development environment. It's so much more efficient to do it on another machine, and most of the things I've said sort of applies to both Macintosh, Windows, and also Linux environment. Kick Assembler is Java, so it runs on all three. Vice could be built for all three. Sublime, I think, is also available for all three. At least I know it's available for Macintosh and Windows, where I run the Windows one. And then Swaffa's glue that makes it sit together also runs on. Yeah, that's also platform independent, because it's just sort of configuration of the of Sublime. So, oops. That was everything I had to say for today. Thank you so much for listening, and again, humble thanks for taking the time, and I do appreciate that you at Transmission have taken your time listening to this rather than having a chat with your buddies on location. Everyone at Transmission, hi, and looking forward to seeing you somewhere in the near future, and all the best. And if you are watching this on FairLight TV, don't forget to subscribe, because you do want other things such as this one as a reminder in your inbox. The little clock button is also needed for some strange reason, so do click that one as well, and bye bye.